This example covers rising and falling edges, which is something that is really important to understand exactly what's going on inside the PLC, because when you're monitoring, it's really unlikely that you'll actually catch the event happen because it's only active for one scan of the PLC. So here we have a normally open contact with a P in it, and the P actually stands for rising, which means that when the signal is changing from false to true, we will give a logical output of 1, but for only one scan. The memory of whether we've changed from 0 to 1 is stored in B10 here underneath, and we're not allowed to put another 1 out until we've seen B10 go to false. So I'll demonstrate. If I set B1 to true, we didn't see anything happen, but B10 now has the value of true in it. And when I set it to 0, B10 goes back to false. Now, the reason we didn't see anything is because it happened so quickly that the monitoring system didn't pick it up. Our PLC is running a lot faster than our monitoring capabilities. So what we would need to do in that instance is change B3 down here to a set coil. And this time, if the set coil is set to true, then we know that B2 actually executed. So now I've set B3 to a set coil. And if I turn B1 on, we can see that B3 is now true. So what's happened, although we didn't see it, is B1 became true. The P for the rising edge then set a logical 1 on this section here, turned the coil on, which turned this normally open contact to true, and then set B3. And because B3 is a set coil, it's remembering, or the value is set to true until the reset happens. We don't have a reset coil here, so I'm going to go ahead and just set it to 0 directly, and it doesn't go back to true because this will not execute again until it sees B1 go to 0 and then B1 go back to 1. The monitoring did actually catch it, that scan, so you can get lucky sometimes. The whole thing went to true. We saw this whole network go to true and then this network go to true. But in a typical case, you can't rely on the monitoring actually capturing that, which is why we set the set coil. I've now updated our P to a N, which is falling or negative. P stands for positive, N stands for negative. But typically, we talk about rising and falling edges. So with our negative edge here, or our falling edge here, when B1 becomes false, that's when we send the logical 1 now. So I can set this to true. And we see that B3 does not turn true. But when I send it to false, now B3 is set true. And we can actually do the same as what we're doing here to coils as well. So now we've moved our rising edge detection to the coil. So our positive is in the coil. And again, I did that just by double clicking and changing it to P. And I've also changed our rising edge here to a standard normally open contact. And basically, it's exactly the same output. If I turn B1 on, we can see that B3 is on, but its preceding logic is still showing false because B2 was only active for one scan. The nice way of doing it sort of this way, or the nice thing about doing it this way, is that we can see that it's a lot more visual that B1 is on, but B2 has already been set to true by this coil, and this coil is not doing the action because it's already been executed once. It's a lot more visual, I feel, than the contact here, despite it showing the same thing. I think it's because you can see the preceding logic should be setting this to true, but it's not because it's already being executed. So if I set this to false, you can see that it stays true on B3, but B10 has gone false as the memory for the coil. And when I set it to true again, nothing happens because B3 is already set to true. So yeah, works exactly the same way. If I change the coil to a falling edge or a negative coil, we can see that we have exactly the same thing as when we had it on the contact over here. Set this to true. Oops. Set this to true here, and the memory is set to true, but nothing happened to the B2 variable. And then when I set this to false, we see that B3 is set to true because this executed for one scan. So that's the basics behind rising and falling edges when using coils. However, there is an alternative way as well. If we look in our instructions tab, under the bit logic operations, come down to the bottom, we can see that we have P-trig, N-trig, R-trig, and F-trig. So effectively, this is the coil, and this is the contacts. So if we put this here, P-trig, we're asked for a memory tag. Sorry, this is the contact. We're asked for a memory tag, so bools.b10, and then this would provide an output for us to put a coil on, where we can put bools b2 again, and then load that to the PLC. And now if I set b1 to true, we get the same output, which is b10 is set to true, b2 executed for one scan, and set b3 to true. So different way of doing the same thing. Personally, this is my favorite way of doing it because it's really, really obvious that we're using rising edge or falling edge triggers. And I'll just go ahead and show you the equivalent N-trig. So I've changed that to N-trig, and we can see that I've already reset B3 to false. So when we set B1 to false or 0, we should see B3 go true, which we do. So that's the other way of using P-trigs and N-trigs, and it's also just worth noting that you can change it quickly by double-clicking and choosing which way round you want it to work. And finally, we have the R-trig and F-trig. So when I drop this one in, something a little bit different happens. It asks us for an instance. Now we're currently working in OB1, so I can't create this as a multi-instance. It's got to be single. But click OK, and this actually creates a small function block, which we would need to move B1 to here and delete this, and then move B2 to here. This actually does the same thing that we've done with other examples. It's still just going to detect a rising edge, but it creates data to hold the status instead of us defining a Boolean value to do it. In fact, if we actually go to system blocks here, program resources, we can see both the function block that has been created, or rather pulled from the instruction library, and also the associated DB. You'll also notice they've got small locks on them because we're not allowed to change them. But effectively, we end up with our input and output, and then one static bit, which is our memory bit. And that's used to remember whether we're transitioning from false to true or true to false. But in essence, it works exactly the same way. So now that we're online, if I set B1 to true, we see B3 goes true. And when I set it to false, nothing happens because we're transitioning back to false. If I change this to N-trig, which I cannot do by double clicking it because it's now a function block, it's an actual block of data, we'd need to replace this with the N-trig, which we can do from instructions. Sorry, it's F-trig, not N-trig. Drop an F-trig in, create an instance for it, and then we'll just move these over and delete this because we don't need this anymore, and then send this to the PLC. If I set B1 to true, nothing should happen. B3 remains false. And if I set it back to 0 or false, B3 becomes true. So there are the many different ways that we can detect rising edges and falling edges. And realistically, they all do the same thing. None of them have any great advantage over the other. And that's it for the many different ways that we can detect rising and falling edges, or positive and negative edges. But going back to this example, this is my favorite way of doing it. P-trig and N-trig are just very, very obvious what you're using. You're free to use any type of data here, whether it's global, whether it's instance, as long as it's not used more than once, then you shouldn't have any issues. That is something to bear in mind. You cannot use the same memory tag for multiple p-trigs or any type of rising or falling edge detection. Otherwise, they will get written by other instructions and will cause issues. And it's not something that the compiler will pick up. It's not something that you'll be told is an error. It just won't work. And it could cause unexpected sort of operation of your logic, which could be dangerous in certain situations. So yeah, make sure that you only use this once. That's basically it for rising edge detection.